All right, so that's s is n factorial. Now, what about the size of E1, say? So now E1, what is in E1? Say E1, this is equal to n minus 1 factorial, because it's all the ways that I could have a 1 in the first thing, in the first slot, and then it's all the ways I can do this. So clearly these can be any arrangement, and that's okay. There's n minus 1 factorial ways to arrange these. And in here we can just put like stars, say we don't care what they are. So there's n minus 1 ways. So P of EI then is just the quotient of these two things. So it's just 1 over n. Okay? And this is for any I, Okay? So we got P of EI. Also, I know I have to add up n of them. So that first term is 1. So let's write that down. Write this all out again. But say we have P of E, the union, right? I have n times 1 over n. So we have 1 here. And now I have minus the sum of all the doubles, right? So Pij, Ei, Ej, where n plus dot, dot, dot. Let's just take the shortcut here and say okay. All right, so we need the doubles, and we need the triples, and we need the R1. While I'm here, you notice that this term here, the intersection of all of them, there's only one way for this to happen. So this probability is equal to the, equally likely, it's equal to the size of the intersection, which is 1, over the size of S. So this is 1 over n factorial. Okay. So what about this one? What is this one? So say, what is probability E1, E2? Let's just say they're all going to be the same. All the pairs are going to be the same. There's no favoritism to the first two. So this is just the size E1, E2 over the size of S. But E1, E2 just means this is 1, this is 2. And these are all free to be whatever they want to be. Whatever they want to be. Okay? So these can be anything. So there's n minus 2 of these, right? So n minus 2 factorial, sorry. So n minus 2 factorial over n factorial, which is 1 over n factorial times n minus 1 factorial. So let's, 1 over n minus 1. All right, etc. Say I had r of these. And these were all fixed. Okay, well then the rest are free to wander, right? They're free to wander. R plus 1 to n. So this size here, there's n minus r factorial arrangements. Okay, so the rth term is p. Let's just again use the fact there's no favoritism here. So this is just equal to the size of E1 to ER over the size of S, which is equal to n minus little r factorial over n factorial. I could write it all out too. It's just 1 over n minus 1 dot 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 n minus r plus 1 down here. Oh my God, there it is. Okay, okay. All right, okay, so I think we got them all. So P of E then is equal to 1 minus the doubles, right? So that's n minus 2 factorial over n factorial. And how many doubles are there? Well, out of all n of these possibilities from the n indices 1 through n, I'm choosing 2. So this is n choose 2. Okay, plus n choose 3, n minus 3 factorial over n factorial, minus dot, 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 and we go like this, and then we have plus, eventually, let's just jump to the last one. I have plus minus 1 to the n plus 1, 1 over n factorial. Okay. All right. Let's reduce these now. So this is equal to 1 minus, now n choose 2, that's n factorial over n minus 2 factorial times 2 factorial. So this is just equal to minus 1 over 2 factorial plus 1 over 3 factorial. Same reasoning, right? This is n factorial, cancels here. I have an n minus 3, cancels here. I have a 3 factorial. Minus 1 over 4 factorial plus 1 over 5 factorial. Dot, 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 right? And at the nth term, I get a plus or minus to the n, right? So whatever n is, I get plus or minus minus 1 to the n plus 1, whatever 1 over n. Okay. You can check. The probability of n equals 1 is 1. At 2, it's a half. At 3, I add a 6 back. I get 2/3. Here, I subtract 1/24. So this sum is now 3/8, which is between 2/3 and a half. So the partial sums are 1, 1/2. I add a 6 in, 2/3. I subtract 1/24. I get 3/8. That's 0.375. Sorry, no, I don't get 3/8. I get 5/8. Sorry, I was thinking of. Let's check. And that's all we need to do. I don't need to write them all out, but let's check. So here I have a half. I add in a third. I get 2/3. So now I have 2/3 minus 1 over 24. That's, let's see, 16 over 24. So I get 15 over 24. Yeah, that would be 5/8, right? Okay, so this is 0.66, 0.5 goes up to 0.66, goes down to 0.625 here. And then we'll come back up. So the next one, I add 1 over 120 to this. So let's see, I can do that. That's going to be 75 plus 1. So that's going to give me 76 over, so 38. So I think it's 19. Sorry. All right, so 15 over 24 plus 1 over 120 is 50, 75, 76 over 120. Let's divide by 4. I get 19 over 30, right? No, that doesn't make sense. I'm taking too long. Okay, it doesn't matter. We keep going. So you see, the final number is going to be between any two pairs because these are decreasing in size. So the window keeps getting smaller. So the final number is between 1 and a half. It's also between, now I know more specifically, a half and 2/3, and now I know it's between 2/3 and 5/8, etc. And in other words, my error here at this point is 1 over 120, so it's already pretty good. So we could basically already answered this. If we want to find the actual limit as n goes to infinity, it's not too hard. We can just write it like this. We have p, so at n, say n equals, say, little n, we have p of e is equal 1 minus 1 over 2 factorial plus 1 over 3 factorial minus dot 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 plus or minus 1 over n factorial. Now, you'll remember e to the x is equal 1 plus x plus 1 plus x squared over 2 factorial plus x cubed over 3 factorial. So e to the minus 1 is equal to 1 minus 1 plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial, etc. So in other words, p of e looks a lot like, so these cancel here, right? So e to the minus 1 is actually is 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial. So p of e looks like this. It looks like the negative of this. It looks like 1 minus the negative of this. So it's 1 minus e to the minus 1. Okay, which is equal to, let's see, e minus 1 over e. Did I do this? I think this is 0.37 to a nearest approximation. I had done it in the lecture. This is approximately equal to 0.63. Okay, maybe 0.62 something. And that should be okay. Yeah, 0.625. I think it's actually like maybe 0.6290, something like that. Okay, something like this. So if I take more and more and more, the probability that at least one person picks their own hat, or at least one of the, so if I want to think of these as being hat people picking, and these are the hats that are theirs or something, or I want to just think of whether a random permutation will match here. As I take more and more, the probability that at least one of the digits matches is about 62%, 0.63 about. All right, so that's a little fancy of an example. It's a famous one, though, so if you do probability, you may see that again, so it will help. The next lecture will be on conditional probability. We need to move forward now. It was fun doing problems. Thank you.